Hello everyone. Welcome to Pre-Algebra. This class is intended for students from grade 4 to grade 6. This Pre-Algebra class is to prepare you for the next up algebra curriculum and also teaches you problem-solving techniques for later math competitions. So let's start our first lesson, Property of Arithmetic, Part 1. In this lecture, you will learn two very fundamental and very important properties. We will first understand these properties and then learn by example. The first property is commutative property of addition. It says when we add numbers together, changing the order of number does not change the sum. So say we have two numbers represented by A and B. Adding B to A gives the same result as adding A to B. Another way to understand this is, say if A represents an apple and B represents a banana. So A plus B means we first received an apple and then we got a banana. So we have an apple and a banana in total. Now if you look at the right side of the equal sign, which is B plus A, this means we first got a banana and then we have an apple. Although the order is different, but in the end, we also have an apple and a banana, so the result is the same. Let's look at our first example, 1 plus 50 plus 99. So if we follow the order of operation, we would add 1 to 50 gives 51 and add that to 99. So here you can see there's a 1 and a 99. If we add 1 to 99, that will give us 100, which is easier to compute. So we're going to use commutative properties to do that. So in this case, we would change the order of 50 and 99. The expression becomes 1 plus 99 plus 50. So this will give us 100 plus 50, which is 150. Now, if a number is being subtracted instead of being added, can it still be moved around? Subtraction is not commutative. That is, 2 minus 1 does not equal to 1 minus 2. So to change the order of a number to be subtracted, you must move both the number and the minus sign in front of it together. Another way to think of it is a number is always bounded with the sign in front of it, being it the positive sign or the negative sign. When repositioning, both the number and the sign move together. This might sound very abstract, so let's look at some examples. Here we have 1 minus 2 plus 4, having both addition and subtraction. If we want to switch the order of 2 and 4, we switch them by taking the sign in front of them with them. So we're going to switch plus 4 and minus 2. So this gives us 1 plus 4 minus 2, which is 5 minus 2, which is 3. Let's look at an identical example, but with bigger numbers. 100 minus 200 plus 500. So 100 minus 200 will result in a negative number. So let's switch the order of 500 and 200. We again take the sign in front of them together. So this becomes 100 plus 500 minus 200. And this gives us 600 minus 200, which is 400. By now, you might wonder, when should we use commutative properties? Why do we reorder numbers? We're going to illustrate the answer using this example. When we look at this problem, 120 minus 500 plus 880. The usual way is to take out a scratch paper, compute 120 minus 500, which gives minus 380, then plus 880. Now, if you take another closer look at the numbers, you see there's a 120 and there's a 880. So you start to sense the presence of potentially a 1000. It's always easier to compute on numbers with trailing zeros, such as tens or hundreds or thousands. So we're going to reorder the numbers to achieve this by switching plus 880 with minus 500. So this becomes 120 plus 880 minus 500. And this results in 1000 minus 500, which is straightforward. The result is 500. In the next few set of slides, we're going to look at some practice problems together. So you can pause the video to solve it and then resume to view the solution. Now, if you computed this problem simply using order of operation and calculated the numbers from left to right in order, pause the video again and think of another way using what we discussed. So take a look at the numbers here. There is a 33 and a 67. These two give some hint of 100, a number that's with a trailing zero that can potentially ease the computation. So let's reorder 55 and 67 by taking the sign in front of them with them. So after reordering, it becomes 33 plus 67 minus 55, which we get 100 minus 55, which the result can be quickly computed in the head of 45. Let's look at our next practice problem. Pause the video to work through it yourself first. So in this problem, let's examine the numbers first. There are numbers equal or close to 1000. Then there is 788 and 1212. If we move plus 1212 next to 788, can the sum of these two numbers give us another number that has trailing zeros? Let's try. So we move 1212 with the plus sign next to 788. The expression becomes 788 plus 1212 minus 1000 minus 999. Now 788 plus 1212 gives us 2000. Aha! This makes things much easier. We can now simply compute 2000 minus 1000, which is 1000 minus 999. And the result is just 1. Let's look at our third practice problem. Pause the video and work it through yourself first. At a glance here, there are quite a few busy numbers. But let's take a closer look at them first. Look at the unit digit of these four numbers. I see a 6 and a 4, and I see a 3 and a 7. Let's pick 6 and 4, and the number that they belong to. 6 plus 4 gives 10. So that means adding 936 and 264 will produce a number with trailing zero. So let's move plus 264 next to 936. And the expression becomes like this. 936 plus 264 gives 1200. So going from here in the next step, there's one more simplification that can be done. But before we go into it, we need to first look at the second property we're going to discuss today. So for now, in this next step, we will simply compute it following the order of operation from left to right. And that gives 800 as the result. So let's look at our second property, associative property of addition. It says numbers can be added together regardless of how they are grouped. Say we have three numbers represented by A, B, and C. Number C added to the sum of A and B is the same as number A added to the sum of B and C. Let's look at some examples to see how to use this property and how it can help us to compute. In this example, 8 plus 3 parentheses plus 7. Let's first use order of operation to compute this simple problem. Parentheses gets evaluated first. 8 plus 3 is equal to 11. Then 11 plus 7 gives 18. So we put the answer 18 here as a reference. Now we're going to use associative properties we just discussed to solve this problem. Associative property says whether we add 8 and 3 together first or we add 3 and 7 together first is the same. That is, we can associate the numbers differently. So the word associate is essentially grouping, and grouping is essentially using parentheses. So in this expression, using associative properties can be rewritten as 8 plus parentheses 3 plus 7 close parentheses. Now here we compute 3 plus 7, which gives us a 10. 8 plus 10 is 18. The result is the same as what we have in the top right corner. Let's look at another example. 472 plus parentheses 219 plus 28 close parentheses. If we compute or follow the order operation, we would first add 219 and 28, which is 247, then added to 472. The final result is 719. Now let's try solve it in a different way, applying the two properties. First, we use commutative properties to switch the order of 219 and 28 inside the parentheses. So this becomes 472 plus parentheses 28 plus 219. Next, we're going to use associative properties to group 472 and 28 together. So it becomes parentheses 472 plus 28 parentheses plus 219. Now 472 plus 28 is 500, and then plus 219, which gives 719. Our third example, 1 plus 2 plus 3 plus 4 plus so on and so forth all the way to 20. Now if we add the numbers one by one from left to right, we have 1 plus 2 is 3, then add to the next 3, which gives us 6, and take the 6, add to the next 4, which is 10, and so on and so forth. So this requires some decent effort of adding them one by one, up to 20. If no calculation mistake is made along the way, you will have the result 210. Let's again use the properties to help us simplify the calculation. Try to rearrange the number into pairs so that each pair has the same sum. So how to do this? Pair the smallest number with the largest one, and so on. We first use commutative properties to move the numbers in a pattern. The largest number is next to the smallest. Second largest number is next to second smallest number, and so on and so forth. Then use associative properties to group the numbers. The 20 numbers are grouped into 10 pairs. Each has a sum of 21. So adding 21 10 times is 21 times 10, and the result is 210. We touched upon grouping using parentheses. Let's look at some general rules of inserting and removing them, especially when there is subtraction involved. Now, if a plus sign is in front of a parentheses, to drop them, we simply just remove the parentheses. And in an expression when there is minus sign in front of the parentheses, to remove them, we change the sign for the numbers inside. So in here, to remove the parentheses around b plus c in the first expression, b plus c becomes minus b minus c. In the second expression, to remove the parentheses around b minus c, it becomes minus b plus c. For a situation when we want to insert a pair of parentheses into the expression, such as when we want to group numbers together, if the place to insert the parentheses has a minus sign in front of it, then change the signs for the numbers to be grouped into it. So in the first expression, a minus b plus c, if we're to group b and c together, then minus b plus c becomes minus parentheses b minus c. So in the second one, to group b and c together, minus b minus c becomes minus parentheses b plus c. So in this problem, take a look at the numbers and you will notice some pattern. So we have 2, 12, 22, 32. Then we have 8, 18, 28, 38. If you add the first number 2 with the last number 38, you get 40. Now if you take the second number 12 and add it with the second to last number 28, the result is also 40. So we're going to try pair up the numbers so that the operation on all pairs result in the same number. Okay. So we first take up the parentheses. So this expression only have additions, so the parentheses can simply be removed. Then we're going to use commutative and associative properties to pair up the numbers in the way we just discussed. So using commutative properties, the 2 and the 38 are next to each other. The 12 and the 28 are also next to each other. Then it's the 22 and 18 and 32 and 8. Okay. Now we're going to group the pairs together using associative properties. So here we have 4 groups, and the summation in each group is 40. So the quick answer is 4 times 40, which is 160. Okay, let's practice. Pause the video and solve the problem yourself first. This problem is identical with the previous example. So rearrange the number into pairs so that each pair has the same sum. Pair the smallest number in the first group with the largest number in the second groups. So the 10 numbers are grouped into 5 pairs, and each has a sum of 50. The 5 groups sum together, and the answer is 250. In this example, we have a lot of subtractions. So first, let's switch the order of minus 400 and minus 220. So the expression becomes 1400 minus 220 minus 280 minus 400. Now in the next step, we're going to group 220, 280, and 400 together by putting the parentheses around them. So because there is a minus in front of where we want to insert the parentheses, the sign inside are changed from minus to plus. So it becomes 1400 minus parentheses 220 plus 280 plus 400, close parentheses. Now if we evaluate the parentheses, it becomes 500 plus 400, so which is 900, and 1400 minus 900 is 500. We're going to introduce another method in solving and simplifying an expression. When a number is close to tens, hundreds, thousands, or 10,000, etc., create a group that has a number with trailing 0 plus or minus another number that's equivalent to the original, and then do the computation. So let's illustrate this with a few examples. So here we have 423 plus 99. 99 is very close to 100, which we all know is 100 minus 1. So here we create a group of 100 minus 1 and replace 99 with it. So the expression becomes like this. Next, we're going to drop the parentheses. Since it's a plus sign in front of the parentheses can be dropped as is. So it becomes 423 plus 100 minus 1, which is 523 minus 1, which is 522. Using this method, instead of operating directly on 99, we kind of ran our operation on dealing with 100 and then minus 1, which made things easier and quicker. In this example, instead of 423 plus 99, we're going to look at minus 99 instead. So we again create a group of 100 minus 1 and replace 99 with it. So the expression looks like this. We proceed to remove the parentheses. Since it's a minus sign in front of the parentheses, 100 becomes minus 100, and minus 1 becomes plus 1 after the parentheses are dropped. So we have 423 minus 100 plus 1. So this gives 323 plus 1, which the answer is 324. Here's a set of practice problems you can work on at your spare time. The solution to each one is also posted here. For the first 4 problems, the hints are provided. They're in color codes and some intermediate steps. For the next 5 questions, the answers are provided. If you solve them using only order of operations, try a different method, referring to the concept we talked about today. Okay. So this concludes our first lecture, and we'll see you next time.